you were babysitting, would you rather charge $5 for the first hour and $8 for each additional hour, or charge $15 for the first hour and $6 for each additional hour? So your job is to figure out which of these would you rather and why. And I'll give you some time to think about that. Which one would work?
So I think it depends on how long it is.
Okay, so give me an example.
Like if you're babysitting for I'm really not going for let's say if you're babysitting for 6 hours, like the first 6 hours.
Okay.
The first one was
Okay. So tell me how you found that amount of money.
I just kind of randomly decided to do the 6 hours, and then I took the 5, I took the 8, and I moved to the 5 and 6. And then I added 5.
Okay, so you took the 8 and multiplied it by 6. Is that what you said? Okay. And then did what?
I added the 5
To get. Okay.
and then I did the same amount of time for the other one.
So what would that look like?
It would be 15 plus 6 times 6 is
And how much was that?
51. And I just kept going back to see what the most.
You went up in hours. Okay. What did you get to?
I just ended.
8. And at 8, what was the price?
It was 69 and 69.
Okay. Anyone else?
If it depends on how long you're babysitting for. So if it's under 5 hours, I would do the second one because you get more money with that one. But if it's 5 hours or above, I would do the first one.
Okay. What was an amount, like what was the amount of time that you put in?
I started with 5 and I got the exact same answer for both.
Okay.
So I wanted to test if it went up on, like, to see if 6, I used 6 as an example to see if it went up on either. And then I went and checked for, and it went on down.
What were the answers for?
I got 45 and then 5 hours. And
30.
But
32, 37, and 24,
That's odd.
30.
yeah, 39. So it really just depends on how long your baby's sitting.
Guys, I need you not to be talking while other people are talking. So, yes, agreed. If you're going for a shorter amount of time, so maybe you are watching kids while parents go on a date, the second option would be better. But if you're doing it like for an extended period of time, overnight, the weekend, something, you want to go with the first one because that will give you more money than you. Okay. Today, we are going to start our new unit. Yes.
When you want dinner at school?
So I have them. They're in the grade book. And then when we finish, I'll let you guys see them. When we finish our notes for today. Look at your course calendar first. So we can pick out some important dates. One, if you haven't done these yet, your linear regression and word problems, Delta Math is due tonight. It says 2B1, but the parallel and perpendicular were already due. The Delta Math for what we do today is due next Friday. And then the Delta Math after that week is a weird week where you guys don't have school that Monday, Tuesday, or Friday. So it'll be due the last day of that week, which is the 9th, so that Thursday. We're going to finish these before Thanksgiving break. So quiz on the 13th, test on the 15th, flex day on the 17th. I'm debating on whether we do another flex day before we go on to Thanksgiving break or not. But keep those dates in mind. If you've not finished your test, you may have time after we go over this lesson. If you don't want to do that today, you need to do it before our next test or by the next test, which is that Friday. I'm sorry, that Wednesday. So keep that in mind. So everyone should have these notes in front of them. Go ahead and put your phones away. This unit is about systems of equations and different ways to solve it. So systems of equations, we're going to have more than one. If you don't have your calculator, go ahead and go grab it. We all make sure you put away. Thank you, Ivan.
Está 20. Can you stop?
What?
What'd you call me? Not Savannah.
Okay. So before we get into the how do we solve the system by graphing is what we're talking about today. We're going to talk about how we can determine if something is a solution or not. So this kind of ties back into when we were solving equations in general. So think about when we were solving equations in general, we got an answer. How could we double check to see is this the correct answer or not? So at the end, I get x equals 3. How do I know that 3 is actually the answer? You put it back in. Same thing here. When you have your two equations and you get some answer at the end, you're going to put it back into both equations to see does it work. If it works for both, it's a solution. If it does not work for one or both, it is not a solution. So let's test this one. I'm going to put my x in for my x's and my y in for both my y's. I'm going to do this one at a time. So 2 equals negative 1/3 times 3 plus 3. And then if we were to either put this in the calculator or start to simplify, this would give me negative 1. Would negative 1 plus 3 give me 2? Yes. So I can say that part works. But I have to check the other one, because if it doesn't work for at least one of them, then it won't work at all. So same thing, put these back in here. 2 equals 2 times 3 minus 4. We have 6 minus 4. Is this the same thing? Will it give you the same thing? Yes. So because it works for both, I can say yes, this is a solution. But if one of them had not worked, it would not have been a solution. Questions on that? We're going to try one more, but we're going to do one of these ones, and then I'll let you guys try some. So for this one, number 3, we do not need to solve this. it's fine as is. We're just gonna do the same thing. Put these numbers in for X and Y and see if we get the same answers. So for the first one, 4 minus 4 times negative 2 equals 12. And you can put this in your calculator all at the same time or simplify each individually. This will become a positive because of the negative, 2 negatives. Will 4 plus 8 give us 12? Yes. Alright, let's try the other one. Now we have 3 times 4 minus 2 times negative 2. We'll have 12 plus 4 equals negative 4. Will this give us negative 4? So because this one does not work, this cannot be a solution. Do we have any questions on that? I want you to try the other two, 2 and 4, and then we'll come back and we'll talk about those prior to lunch. Okay, for number 2, did we find that that was or was not a solution? Was not. What about number 4? Was that or was that not a solution? Did we need to see either of those? So that would be when you get your answer at the end, double check to see did you get the right answer. Guys, I need you not to talk over me. For these bottom ones, wherever it crosses would be your solution. So what would the solution be for number 5? What is that order pair? Negative 2, negative 1. So when you go to write your answer, you're going to write it like that. When we come back from lunch, you're going to write the system equation. Okay. So not only do you need to state the solution where they cross for this, but also write the equation for the 2 graphs. So this is going back to when you were writing equations from graphs. So if I wanted to find the equation of this line, I need to find the y-intercept and points that cross grid lines exactly. So any of these points would be fine. And then write that equation. So the slope of this one would be what? 1/2, but it's going down and to the right, so negative 1/2 x, and then the y-intercept? -2. Then let's do the same thing for the other line. Find where it crosses the y-axis, and then count your slope. What would that slope be?
For 5?
For, yes, the red line.
Maybe it'd be 1/2.
Negative, I heard the negative part, but not the other part.
-2.
It is going over 2, but it's going up.
-3 over 2.
-3 over 2. And your y intercept?
-2, 2.5, 3.
-6.
-4.
Where are you seeing?
Let's try another. It doesn't matter if you find the equations first or the solution first. So let's find the equations first. Of this line, find the slope.
Not a 4.
This,
No, down
this, is -1. What would the slope of that blue line be? Or the one with dots? -3. Y equals -3x. What's your y intercept? -4. And your equation for the red line, let's find the slope of that one. How much are we going up? How much are we going over for this red line? 4. Up 4 to the right one. So y equals positive 4x. What's our y intercept? +3. Right. And then where do these two lines cross? -1, -1. That would be your solution. We're just going to find the solutions of the next two. If you want to write the equations, you are more than welcome to do so. Where do these two lines cross on number 7? -3, -1. What about number 8? -4, -2. So when we solve systems by graphing, we need to be able to find it on a graph, where they cross, be able to graph, be able to write the equations, all of those different things. I should probably have this in front of me. I know what the next page is. Okay. Go to the next. We're just going to look at the piece at the top. I don't have it up here, but you have it on your notes. And then we'll talk more about it in a second. There are 3 types of solutions. This goes back to when we were solving equations, those same solutions. One solution, they cross somewhere. That would be your one solution. No solutions. They're parallel lines that will never intersect because they have the same slope. Infinitely many solutions because they're the exact same line. So you're going to get one of those 3 and have to write that solution. Go to this page. I'm going to have you rewrite what I just said, / write these definitions. So I said this, but here are the actual definition. Here is the actual definition. Systems of equations has 2 or more equations with the same variables, usually x and y. The solution to a system graphically is the point where the 2 lines intersect or cross. Algebraically is the point xy that makes both equations true. We just did some examples like that. Then these are your 3 types of solutions. Intersecting lines. would be one solution. You would have a point x, y. Parallel lines, you get no solution, or you can write ns. And then the same line is going to be one line drawn on top of the other. So when you draw that, you can either do what this is, or just draw a line and then have double arrows. Either or. But that would be your infinitely many solutions. We're going to do a few examples so that you see how this works, and then you'll have time to practice. The instructions on how do we solve systems by graphing are: rewrite the equations in slope-intercept form, graph the two lines, identify the solutions. Very easily, once you graph them, you'll be able to see whether they intersect or don't, or overlap.
So say slope intercept.
Yes.
Good morning.
I keep meaning to rewrite these because these aren't my notes, but they were used when we had the virtual years, so we created everything virtually. And I keep meaning to redo it and keep forgetting. Right, so let's do one of these, and then we'll move on and do a couple others.
Go back.
Yes, sir. Alright, so if these are in slope-intercept form, you just graph them. If you would like rulers, look at your table numbers and you can grab rulers out of the colorful part. We're going to fill up this graph. I would suggest, if it helps, doing these in two different colors or like writing utensils so that you can see the different lines. I'm going to do them in two separate colors. Right. For this first one, we're going to start at -8. So we're going to point at -8. The slope of this one is what? So I intercept -8, 1. And it's positive 1 over 1, so we can go up 1, right 1 as many times as possible. Fill up your graph. and down one, left one as many times as possible until your graph. When you draw your line, make sure it has arrows. These lines go on forever and ever in this direction. And then we're going to draw the other one. Y-intercept of this one is at +1. Slope is -2. What directions can I go to get that? Sure. You both said two different things. So I can go down and so down and left would give me a positive. Down and right. So if I went left, I would go up and left. So down 2, left, right. Sorry, down 2, right 1. As many times as possible. As you're doing that, you'll see which one crosses. And up to left 1 as many times as possible. Where do they intersect? What is that order here? Close. -5. So you can easily see where they intersect, and that would be your answer, and then that's it. You found the solution. Yes.
For this part, when you have to like graph both of them, will they be polarized? Or do we just have to say where they intersect?
It'll be printed on black and white, so they'll just be 2 separate lines. Alright, go on to the next page. We're going to do number 4 and number 6. So number 4, one of the equations is in slope-intercept form, the other one is not. Whether you solve it first or graph it first does not matter. So let's say we graph this one. We would start at +2 and go up 1, left 2 as many times as possible. And down 1, right 2 as many times as possible. I'm going to rewrite the equation underneath just so I have room to solve. Think about how do we get this back in slope-intercept form? We gotta get y by itself. Get rid of the x by doing what? Subtract x on both sides. We have 2y equals -x plus 4. Divide everything by 2. So that y equals -1/2 x plus 2. Now, before we graph these, what do you notice about our 2 equations? They're the same. Which is going to be what type of solution?
Same one.
Or like infinitely many. So you can put the infinity symbol or IMS. When you graph this, since you already have one graph, you could just extend your line and draw another set of arrows at the end. Or you could highlight over it. That would show that you've drawn 2 lines, even though you didn't. Or if you want to draw the 2 lines, you can redraw it in a different color over top of it. You have those choices. Questions about that one? Right, and then let's do number 6. I'm going to go ahead and graph the one that's already in slope-intercept form, starting at +5. The slope here is 1, so up 1, right 1 as many times as possible. Down 1, left 1 as many times as possible. Let's solve the other one. Subtract x on both sides. And how would we get y by itself? Not by y, but -1. So y equals x minus 2. Before we graph this, what do we notice about these 2 equations? What did you say? They're similar. How so?
The x and y are not flipped, but like
Parallel.
These are going to be parallel because they have the same slope but different y-intercepts. So let's plot this one. So starting at -2, but the slope is the same, going up 1, right 1 as many times as possible. So if they never intersect, what would be our solution? Do we have questions about that one? Look at the ones we skipped over, 2, 3, and 5 through 8. Are there any questions on any of those we want to see if you go over? Either.
Number 8 is the top column, just that one.
So just for the top piece, you have to remember your Hoy bucks. If you thought it was going, it is not. If this is an x equals, this is going to be a vertical line. So on your x-axis, find when x is -2 and draw a vertical up and down line. You said you don't need me to do this one. Just for future, if you get some x equals a number and a regular equation, those are always going to have one solution. Or same thing with y equals and a regular equation. But if you have 2 x equals or 2 y equals, those will be parallel. They have the same slope. But if you have an x equals and a y equals, those are going to be they're going to cross because they would be perpendicular. Perpendicular is similar to intersecting. Any others we want to see, do go over, have questions about?
Oh, yeah. What do we put for the solution?
So I didn't actually finish solving it. Would you like that? So we would need to solve this one. Get rid of 3x. And divide everything by -2. So that y equals positive 3/2 x plus 9. So we're going to graph that. It's a positive slope, but I can't go up, so I need to go down 3 to the left 2, as many times as possible. So then where would those cross? So for the remainder of class, you can be working on these things. You have a Delta Math on this due next Friday. You have Delta Maths that are due today. If you want to work on retake work, you can come see me for that. I will be passing out your Unit 2 test if you finish to show you your scores if you would like to do retake work on that.